Hi, good morning, or afternoon. It is afternoon. I have trouble with time and days and weeks. Anyway, like she said, I am a Perch. I am a mad scientist and educator slash professor slash whatever I feel like calling myself on a given day at Boku. I teach web development and I work on open source technology. I go by the NodeBotanist. For the first time ever, about 4 months ago, someone ran up to me and didn't remember my real name. They just remembered I was the NodeBotanist, and that was weird. I'm a GIF aficionado, but this is the only GIF in my talk this time. I might actually be a NodeBot, depends. I wear an awful lot of NodeBots, and I'm an author. I wrote a chapter in Make JavaScript Robotics, which is already out, and next month I will be debuting Introduction to JavaScript Robotics with Johnny Five with Pact Publishing, so keep an eye out for that. So background of I talk about thin clients and the future of JavaScript, Internet of Things. So what a thin client is a layer of C that offloads as much work as possible to cloud services. Simple tasks are done in this layer and then handed off via HTTP or some other form of internet communication to a server. Example tasks that you would complete on a microcontroller using a thin client setup are things like read a sensor and then updating a variable that can be accessed via an API, or fire an event when a button is pressed, or take an array of colors and light up some LEDs. Server tasks, this is where you'll do most of your logic in a thin client setup, or thin client, not thin server, setup. For instance, the server would parse hash 88AA25 into RGB 138.16837, or really any string work. If you've ever programmed in C, working with strings in C is painful, to be nice about it. It's much easier to work with strings in JavaScript, or any other language really, than C. On your server, you would call a third-party API on that button press event I mentioned from the thin client to send a text message or write a tweet or etc. The benefits of thin client, they make a lot of robotics platforms from 50 to 60% JavaScript via Johnny 5 to what I like to call 98% JavaScript. We're going to get closer to 100% JavaScript, which I'll talk about in a little bit. Node servers and robot code get along really, really well. If you've ever programmed with Johnny 5, you know that JavaScript and Node work really well for robotics because events. Basically, a robot is a series of events, and writing an evented system like that in JavaScript is very easy. Events and set timeout and set interval, writing those on a C system is, they're always blocking, so it's very tricky to write things that run on a timed loop or write things that run after a certain amount of time. Asynchronous HTTP requests and et cetera are also much easier on a JavaScript server than they are on a C client. So the thin client drawbacks are you mostly have to stay connected to the internet. You'll notice I check my phone every 5 seconds. That's because I'm making sure I still have a tether to the internet. And it does still take some C work, or squirrel in the case of the demo I'm about to show you. So the thin client I have working right now is the Node Sash. So the Node Sash is the belt. So if you go to Twitter and you write a tweet, that is, whoa. That's not what, I didn't mean to reply to anything. There we go. I'm on stage. Let me make this a little bigger. Whoa, that CSS is hard. And I'm going to type out, I'm on stage at #EmpireNode. I'm actually going to shrink this a little bit so I can see it. With the Node Sash, and it's a hashtag, and it's great. Also, comma, blue, because I can't think of a clever way to work a color into that sentence. And I'm going to hit send. I'm going to wait a few seconds. So what's happening right now is I have a server sitting in a DigitalOcean droplet that is watching Twitter, and it's watching the Node Sash hashtag. So I believe every 10 seconds right now it's polling. I'm working with someone to get streams working properly on it. And actually, I'll show you the code while I'm waiting for it to update. So this is my Twitter color server for the code for the Node Sash. You'll notice an array of CSS colors. That's for the regular expressions I do. So I tell Twitter to search tweets for the hashtag NodeSash, and then I internally keep track of which tweets have already been shown or not, so I don't repeat colors. Anyway, so it checks the timestamp and makes sure the tweet is less than 40 seconds old. I put 40 seconds because lag. basically. If it's not already shown on the belt, it uses regular expressions to parse out any CSS parsable color, and then makes a request to an electric imp server. So an electric imp is a microcontroller made by the Electric Imp company. I believe they're still called Electric Imp. And basically then you have an agent and a device in their particular cloud services setup. My agent is remarkably simple. Whenever I get an HTTP request, if there is a query URL set to color, it will send the color to the device. Now the device looks a little more complicated than it is. All it does is keep an array of colors and re-render those colors every 5 seconds. And, it worked. So that's kind of the interactive portion of this talk. If you want to tweet at the hashtag NodeSash, it will add the colors to the belt, so long as my phone decides to keep service with T-Mobile. So that's the concept of a thin client, is I'm doing as little as possible as I can on the Wi-Fi enabled microcontroller and doing as much as I can in cloud services, i.e. Node in this case. However, this is a very language agnostic concept. My server could be running Python or Ruby or Perl even, really, if they do that. And, that'd be cool. Like, it'd still work. So the concept of thin clients is not JavaScript specific, but the rest of this talk really kind of does get JavaScript specific. So I'm going to talk about my new favorite thing, and that is the Particle Photon. It is a $20 microcontroller that connects to the internet and has cloud services included with it. It's created by a company called Particle. You might know this as the Spark Photon, or you might have messed with a Spark core. Spark rebranded as Photon or Particle a few months ago, and the Photon is the successor to the core. Half the price of the core, much more stable Wi-Fi. If you've ever used a Spark core, Photon fixed most, if not all, of its Wi-Fi issues. Plenty of GPIO capabilities, 7 PWM pins, several digital pins. You can do I2C and SPI. There is a Node.js SDK for playing with the Photon. Emily Rose, Nexilove on Twitter, wrote it. Pretty great. If you use Johnny 5, there is also Particle IO, which was written by R. Waldron and several others. And Voodoo Spark is the firmware that runs on the the Photon to make the Particle IO wrapper work. And that was written by the Chris Williams that runs JSConf. So anyway, I'm going to show you what it looks like because it's kind of small, but you can see. So it's like comparatively to my index finger, it's a very tiny microcontroller. It's very power efficient as far as I've been able to test. And $20 for one of these. It's pretty great. And I like the Photon a lot. And I like the Node SDK that comes with it a lot. However, when you use Johnny 5 with Particle, they have to be connected to the same Wi-Fi network, and the code has to be running on a computer on the same Wi-Fi network. So if I were to implement the Rose pin, which I'll show you all in a minute, in Johnny 5, I would need the Node server running on my laptop connected to the same Wi-Fi internet. I wouldn't be able to tether it to my cell phone like I am today. And plus you have to write, but the thing about thin clients is you have to be able to write C, or do you? So I've written a library called Babble Bots. It's in very early stages, but what it does, I don't even have a logo yet. I'm going to show you the GitHub repository, if I can remember where, there we are. Yes. So Babble Bots, basically what it does is you can declare your build in a JSON object or a JS object literal, to be more specific, and Babble Bots will translate your object literal into a thin C client that will dispatch events, accept variables, and interact with the Photon SDK so that you don't have to write any C for a thin client Photon setup. You would basically declare your build in Babble Bots, write your Node server using Particle's Node SDK, and all JavaScript all the way down. So going from 98% JavaScript to 99.9% JavaScript. As it stands, you have to copy and paste the C into your into the Spark IDE, which looks like this. Which I'll show you the full steps in a moment. But yeah, 99.9% JavaScript. You just have to copy and paste some C instead of writing any C. Yeah, so I don't have a ton working yet, but what I do have is really fun, at least for me, and most people tend to like lights. What I do have support for right now is declarative NeoPixel builds and a general set pin function that allows you to set the value of any pin, PWM or digital, from a cloud server. So yeah. how it works, like I said, you declare your build in a JS file. I'll show you what the JS file looks like in the demo. There's a concept of a build, which is basically your declared JS object, a platform, which is the Photon in this case, and components, which is NeoPixels in this case. I'm hoping to implement more components for Photon and then branch out into other platforms, such as the electric imp and probably, I can't remember what the third one would be, but for now, Photon and Electric Imp would be my 2 targets. And Babble Bots translates this into a C-thin client for you. When Electric Imp is supported, it will translate into Squirrel, which is the language that Electric Imp uses on its microcontrollers, which is very C-like. But it's like C and JavaScript. Like, they tried to bring the parts of it together, and it's kind of interesting. I have some, yeah, I can talk about that at the after party if you like. So for the demo, I'm wearing a rose. I'm a crafter at heart. I learned to crochet when I was like 5, and I learned to knit when I was 8. This is a hand-designed and knit rose with little like tendrils and stuff, and it's got 7 NeoPixels in it. And it is attached to a particle photon and a battery, because you know, no free power. And it is connected to a server. So I'm going to show you it working before I break it, honestly, because it's live coding, so I'm going to break it. Right now it's tied to pumpkin.nodebotanist. That is because Tuesday I was giving a very similar talk, and the conference organizer had me build he built the pumpkin. I built the internals, and so there was a pumpkin that sat on stage for this entire conference, and you could go to this website and change the color of the pumpkin as it sat on stage. There's some fun bits in the speaker videos where like you see people fighting over what color the pumpkin should be. Anyway, this rose is also tied to that. So I can pick a color here. I'm going to pick back a purple because I like that color. I'm going to hit submit. I'm going to wait because there is a bit of lag between my laptop connecting through the visitor Wi-Fi to my cloud server to my cell phone, which, do I still have signal? I do still have signal. It should light up in a moment. And it'll be kind of dim because it's lit up here. But anyway, oh, it did go. You can, here, I'll turn on the photo booth. You can kind of see it. See that little purple stripe right there? Yeah. Well, thank you. So how this works. So I'm going to open up I'm going to go into my rose folder. That's what I'm going to do. I'm going to open up Sublime Text. And funny story, I didn't have my license this morning either. New laptop. I actually just had to like copy and paste it in, but I did remember to do that luckily. So this is my declared build. It looks just like a common JS module because it is essentially a common JS module. I'm working on making it so you don't even need to make it a common JS module. It'll just be a JSON file that Babble Bots will parse for you. You give it a name because that's what it names the C sketch, which is, if you've never used Arduino before, they tend to call the bits of C that run on microcontrollers sketches. The platform is Photon, and that's what tells it I want to compile this specifically for the Photon. The destination is whatever folder, because you could have multiple files. In the case of NeoPixels, it will include 2 other C files that control the actual NeoPixels. So it needs a destination folder. And then I declare my components. I only have 1 component for this build. Its name is NeoPixels. The reason I gave it a name is I do have builds with several strands of NeoPixels, so I wanted to be able to name them so that the variables would work out. The type is NeoPixels. That's much more hard-coded, basically. It needs to be supported. The pins is an object. NeoPixels only really requires 1 pin, and that would be data. So I declared that to be D2, which is a pin on the Photon. And then I give it some options. Length is 7 because there are 7 RGB LEDs on the disk inside this rose. The type is the chip that runs the RGB LEDs, in this case a WS2812. And custom functions is basically, so Photon gives you the idea of cloud functions, which are functions that are written in C and sit on the microcontroller, but you can call them using an HTTP request. So in this case, I've said I want to include the custom function pixels, and I have written this function and included it in the library. So when I go to my terminal, oh, they didn't set the timer. I have no idea how long I have left. So I'm just going to keep going. So Babble Bots runs as a command line tool. And I'm going to increase my font size so y'all can see it. And then I'm going to run Babble Bots on that JS file I just showed you. And then I'm going to go back to Sublime Text to show you what happened. And so you can now see, well, or not. probably not, that there are now 3 new files in the folder. The first is rose-thin-client.ino. And let me change this to C++ so you can see the text highlighting. So this was compiled by Babble Bots. It includes neopixel.h, which is included here, and that's this, like I said, the C that controls the neopixels. And it's, oh, wrong file. And so, yeah, we've got your pixel pin, count, pixel type. It declares the strip for you. It gets everything set up. And it doesn't actually do anything in the loop. So here's why. This is the custom pixels function that I mentioned being included in the build. I wrote this previously. So when you call a Spark function, you kind of have to get creative with how you implement these, particle functions. You only get one argument, and it's a string of 60 characters or less. So in my case, I implemented the pixels function, which takes an index, a bar, and 1 or more colors represented in hexadecimal. The index can be 0 through whatever integer you have on your NeoPixel strip, or it can be all. That's because I didn't write 2 separate functions when I only get 4 per microcontroller. That's the other limitation. You only get 4 per Photon. So I wanted to overload this. It broke every software engineering best practice in my body, but you gotta do what you gotta do. So this one can do any index or all. If you select all, you send 1 color, like FF would be white, and it will do all of the pixels in that strip. Otherwise, it will start at the integer index given on the left side of the bar and assign 1 pixel at a time each color that is sent in on the right side of the bar and cycle through it. I wrote this in C. It took me several hours of painful reminders that C is not JavaScript to write this, and so that's part of what inspired this, is I didn't want other people to have to try to learn C to get started with this. So Babble Bots was born to kind of allow y'all to compile out of JavaScript instead of writing C, and crying yourself to sleep at night with a glass of whiskey, as some of us may have done. So, what I'm going to do, I'm actually not going to attempt to flash it because the Wi-Fi is shaky and it could brick. I've bricked a Photon this week. So what I would do, though, I can walk you through that at least, is I would copy this INO file. And I go over here into the build. And I have to paste that. Now, the only thing I do have to change, and again, this is also being worked on, is I have to tell it to use their cloud version and not my local version, because it doesn't know where to get my local version from. So, but I am working on this. And I would hit this lightning bolt button, and it would, over the Wi-Fi, update the firmware on my Photon, and you all would be like, wow, that's amazing. But that's not even me, so like it wouldn't even, that was Particle. They did that. Anyway. All right. The other function I have, which I will show you, is, nope, not that one. That one is the setPin function, and, oh, it's Babble Bots, not Babble. Would help if I could remember the name of my own library. There we are. And so, oh, I've got to open up this folder. All right. So, in this folder, I've declared a build, and it doesn't even have any components. It just has options on the main build, setPin included to set to true. And so when I go into the compiled C++, transpiled, compiled, whatever you want to call it, in the void setup, it sets up the particle function setPin, and the setPin function takes a string command, which very similarly to the NeoPixels command I showed earlier, takes a pin on the left side of the bar and a value on the right side of the bar. You can set any pin A0 through D7 through this function. The way you do that from a cloud perspective is you use the JavaScript SDK for Photon that I mentioned earlier. There we are. And CD server. Yeah, it's always fun to do this on the fly, isn't it? ST. There we are. So here's the server that runs the rose and therefore the pumpkin. It is currently just an Express app. I actually just use the Express generator. And then here's where the fun stuff happens. So it serves up a page, and that form posts to add color. And it does all the processing here. It figures out what color you're trying to do, whether you filled out. So there's actually some form validation. I kind of remembered I used to be a front-end developer, and so there's like validation. If you don't select anything, it'll yell at you. Anyway, so it posts to add color, and then the server basically calls up the Spark API, and actually calls up the Spark API at the beginning and gets a list of devices. You see here, devices PR, Spark list devices. And I've actually logged into Spark, and I was smart enough to hide my access token. Gets the devices, and then you can call down here, over here, we say pumpkin.call function pixels with all, and then the bar red string, green string, blue string, which connects back to that particle function I showed you in the compiled C, which then parses out the color and changes all of the LEDs in the rows to that color. So that's essentially what I built Babble Bots for, is to create thin clients without having to actually write the C. Would help if, there we go. So where I'm going next. Docs, and more docs. I will be happy when my docs are half as good as AVR Girl Arduinos, which I'm about to talk about in a moment. Suze is the certified, verified best person ever, by the way. You'll really enjoy her talk. I want unit tests, just because who doesn't want unit tests? The limitations of 4 custom particle functions inside a Photon is becoming strenuous at best. So Voodoo Spark, actually the firmware that helps run Particle I/O, has some interesting insights into how to get around that. And so I'm actually currently tearing it apart to figure out how I can cut out, eat its heart, and absorb its power, as one does. So the future of NodeBots. We're going some really cool places with NodeBots in general. I really have super mega thank yous for Rod for mentioning that the hardware group is not just hobbyists. Hardware is a part of the future of Node, and if you don't believe me, believe the money. The first step in the future of Node is more open source and less about money, and that's that we are building full Node tool chains for robotics. Suze is writing what is called AVR Girl, and if you've ever worked with robotics, you may have heard of AVR Dude, which is a C tool that flashes AVR chips with compiled C code so that they can run. It has no unit tests, and it's very cryptic, and it's, yeah. So Suze is writing AVR Girl entirely in Node, and yeah, it basically allows us to add to these kind of microcontrollers. It's kind of funny. So the Johnny 5 installation process right now, Johnny 5, you don't need Arduino to do Arduino library. The first step in the installation process is to install the Arduino IDE. Not because you actually have to write any C, but because AVR Dude is needed to flash Arduino-based controllers before you can use Johnny 5 with them. Well, with AVR Girl, we don't need that anymore. We can actually just use AVR Girl to flash these microcontrollers with the Fermata protocol, and then we don't even need to download the Arduino IDE. And if you've ever used the Arduino IDE, you'll be very happy to hear that, because it has syntax highlighting, and that's about it from a functionality perspective. Emily, Nexilove, has made a lot of work possible with the Photon SDK, and the Particle folks keep getting better and better about their JavaScript support. So production level, product level microcontrollers are starting to recognize JavaScript as an A-level robotics language instead of just seeing it as a novelty or seeing it as, oh, we need a REST API, but we don't need to like actually have JavaScript work with our hardware. I also created Voodoo Spark installer to flash photons with the Voodoo Spark, because they don't use the AVR chips. AVR Girl Arduino doesn't do that. So I created the Voodoo Spark installer so that you don't even need Particles in browser IDE or any C knowledge whatsoever to get the Voodoo Spark running. JavaScript in our chips is where the other part of our future lies. I wrote Babble Bots with the intense hope that one day I will not need it. There will be a day where we will write JavaScript and it will immediately go onto the microcontrollers. And a lot of people think that's the fevered dream of a mad scientist. And I kind of believe that until Samsung started throwing a lot of money behind JavaScript, until Esperino started taking off, until these chips where you actually just write JavaScript, it doesn't transpile to C, it just goes to the microcontroller, is starting to work. Now, JavaScript is in its very early stages, but they do claim to have a JS engine in 64K. An Atmel chip can easily handle that, and if you add RAM onto it, you could run a JavaScript engine on a bare bones Atmel chip. Another good example of Node on the hardware is the Tesla 2. It comes out in November officially, and while it is technically a Linux computer running Node, running Tesla, they're doing a lot to abstract away the fact that it is running Linux, and you only have to deal with Node. You don't have to deal with installing Node on a Linux machine that runs an ARM processor. Tesla takes care of that for you. So while it is an intermediary step, it's a very good intermediary step. You should get involved with NodeBots. And Babble Bots and AVR Girl and Friends and Voodoo Spark Installer, all these things. Help us test them. All of the libraries I've showcased today are in very early stages and do need a lot of testing on different hardware platforms. In the case of AVR Girl, that's where Susan and I disappeared off to at lunch. We were testing the LittleBits Arduino board with AVR Girl to see if we could get it to work. Write a unit test or something, or docs, please. I need help with docs. There's so much to do. Or a tutorial. I have never heard in my life anyone new to robotics programming anything say, there's just too many tutorials. Like, I Google it, and there's just like 50 pages, and I just can't read them all. I've never heard anyone complain about too many tutorials. So please, if you feel like helping and that's how you feel like helping, don't hesitate because you think it might already exist. You can't have too many tutorials. NodeBots people are the friendliest people. We're a really great community. There is a code of conduct on everything we do. NodeBots core team does not speak at conferences without a code of conduct. Our Gitter channel has a code of conduct. Our pull requests have a code of conduct. So we are a good group of people, and we make sure that our community does not act poorly towards each other, including ourselves. We hold ourselves to a very high standard. So feel free to ask us. Like, approach me at the after party. Ask me how I implemented something. Ask me what you can do to help. I can give you something to do. Suze can probably give you something to do. Like, it's definitely not difficult. So thank you for listening. I am the Node botanist pretty much anywhere. My email is @NodeBotanist. The Sao Tome registry was fun to wrestle with, but now I have a really cool domain, so that's cool. I do have a few thank yous. I'd like to thank Suze and Rick and Emily and my mentor Ray and Donovan Buck and all of the NodeBotters everywhere who have made me confident enough to get up on a stage and write my own library and wear light-up clothing in public and wear a lab coat because I feel like it. And yeah, so thank you. Oh, that's right. I have to do the questions.
Yes.
Okay.
Come on over here.
Oh, okay.
Thank you so much. That was awesome. All right. Dolphins or koalas?
Koalas.
Okay. Least favorite color? Oh, interesting. Okay. Very interesting.
Just because Just because of LEDs. That's why.
Oh, okay. All right. Weirdest thing you've ever eaten?
Oh my god, we've already got a tango.
Tree bark.
Tree bark. Was it in your coffee in New Orleans?
Some kid dared me to eat tree bark.
Oh, okay. Happens to the best of us. What do you like on your pizza?
Pepperoni.
Okay. Favorite lyric?
Oh, I'm leaning on this broken fence between past and present tense.
That was really good. All right. Best gift you've ever received?
Robots.
Okay. Not at all predictable. Country you wish to visit?
UK.
Okay. Favorite word that starts and ends with the same vowel? They get easier. Azalea.
Just because it's the first word that came to mind.
Okay. What is the weirdest word in the English language?
Recalcitrant.
What does that mean?
Means hesitant.
Hesitant.
It's been used on a person, so they were recalcitrant to answer these questions.
All right. No one was. Okay, how do you feel about selfies?
Mixed. They're very good for teaching kids to love themselves and love their own image, but it's kind of scary that we have people dying trying to take selfies. So
Who's dying?
like people falling down steps at the Taj Mahal.
Oh. Yeah.
So, like,
Choices. We all make choices. It's fine. Wh- What was one thing you wish you knew in high school?
I think so.
that robots are awesome.
Okay.
Half of the answers are robots.
If you could switch lives with one person for one day, who would it be? Suze, of course. Of course. Sames. Cutest thing on planet Earth.
Oh,
Suze.
Come on.
It's either Suze or robots.
As a robot would be pretty
Okay, where would you spend your retirement?
island with a skull on it and a volcano. Like a skull mountain.
Have you made that yet? Okay, it's early still. If Lois Lane wasn't a journalist, what would she be?
Programmer.
Okay. What is your kryptonite?
Owls.
Oh, yeah.
I have
Yes.
a healthy respect for owls.
Yes, yes. She was attacked by an owl.
Falcons.
Falcon.
But that's unrelated.
Okay. Who is your favorite comic book artist?
Oh, the woman who did the reboot New 52 of Batwoman for the first 12 episodes. That was fantastic. I
Excellent.
can't remember her name.
All right, thank you. Maybe tweet about it later. Yeah, thank you so much.
Oh, they got my stuff out of the way.